Lesson 1.7 is something called the distributive property. You've probably seen it. You should have seen it. It's a matter of, do you remember it? So the distributive property is how we multiply something where there's two things added or subtracted in parentheses and there's something outside trying to multiply in. So, for example here, this A times B plus C. The A is outside, the B plus C is in the parentheses. In order to multiply this, we take the A and we distribute it. We take the A and we multiply it by the B. So that's where you see the AB there. Keep the plus sign, and then the A times C is AC. You will also sometimes see it written like this, where the A is out back, but it's the same thing. If that A is being multiplied by a set of parentheses, and there's adding or subtracting inside the parentheses, you multiply it by each of the pieces inside the parentheses. So let's practice on this first example here. There's 5 in parentheses x plus 7. So that means I'm doing 5 times x plus 7. How do I do 5 times x plus 7? Distribute. So distribute means I'm going to do what here, Chloe?
Take the 5 and multiply the 5 with the x and 7.
Okay. We're going to do 5 times the x
6.
and 5 times 7.
Don't
Okay.
make fun of me.
She answered. It's all good. So when we multiply this, 5 times x is?
Oh.
5 times x. We multiply a number and a letter. You just put them together. So 5 times x is 5x. And then the plus sign, unless I have a reason to change it, I'm just going to carry it down. 5 times 7, 35. Can I add 5x and 35?
Yeah.
Are they like terms? No. One has an x, the other doesn't. So I can't add them. So we're done right there. Okay, so if you're told to simplify, or multiply, or use the distributive property in homework, it's going to look like this. Okay, example 2. 12 times 3 minus 1/6t. What's the basic that I'm doing here? You don't have to be able to do the math for me, but what am I doing with that 12? We're going to distribute it, right? The 12 is going to multiply by what? 12 is going to multiply by 3 and the 1/6t. Okay? 12 times 3. Well, write it out or grab a calculator. I don't care which. I'm not against you guys using a calculator in here.
Is it very simple?
It is. Okay. 12 times 3 is 36. Unless this 12 out here is a negative that I'm multiplying by, I'm just going to carry my minus sign down. Now, 12 times 1/6 t. Which what I have to be able to do here is I have to be able to multiply 12 times 1/6. Which 12 as a fraction is 12 over 1. So if I'm multiplying 12 over 1 times 1 over 6, what are you going to say? Well, if I just multiply across, it'd be 12 over 6. But we're not going to leave it like that. What does 12 over 6 reduce to? What is 12 divided by 6? What? 2. So then that takes us back to what is 12 times 1/6t? Well, 12 times 1/6 is 2. 12 times 1/6t is 2t. And I went ahead and circled that because I can't subtract 36 and 2t. They're not like terms. Now the 3's out back this time, but that's okay. It's the same thing as the 3 being out front. What am I going to do with this 3 here? Over here I took 5, multiplied it by x and 7. Here I took 12, multiplied it by 3, and 1/6t.
Distribute 3 to the 0.4.
Okay, we're going to take 3 to the 0.4 and
1.1.
the 1.1c. 3 times both pieces. Now, I would say grab a calculator if you're not sure. But if I do 3 times 0.4, what is 3 times 4? 3 times 4 is 12. There's how many numbers after the decimal here? 1. So in 12, I need one number after the decimal and make it 1.2. Carry down my plus sign. 1.1c times 3. Forget the decimal for a moment. What's 3 times 11? 33. If there's one number after the decimal here, my answer I need 3.3, one number after my decimal. Since it was 3 times 1.1c, we're going to say 3.3c. What about 1.2 plus 3.3c? Can I add those? No, because one has a c, the other does not. You guys are quiet here.
I can't even see right now, so.
You need to move closer.
No, my eyes won't stop working.
Ah. I'll tell you what, I'm having issues with when I look out at you guys. That snow is making outside so much brighter that I'm struggling to, like, you know, not be blinded, but I am going to see Kleenexes. Or that way, Robbie? Okay.
I think I got brake cleaner in my eyeballs.
Huh?
What?
You got what?
Brake cleaner in my eyeballs.
Except that you've been here at TC for like 3 periods
It's on
now.
my hands, and I haven't washed my hands. I rub my eyeballs. I wasn't thinking.
Okay, so this next set, ask us to write these as a sum or a difference. What it is right now is it's one fraction. We want to write this so it's basically 2 fractions. It's 2 fractions being added or subtracted. Now, basically what I'm saying here, I'll do the first one with you, or for you, is that this 3 goes with the 4x, and it goes with the 16. So instead of having 4x minus 16 over 3, we're going to put this 3 under both pieces. I'm going to put the 3 under the 4x, so 4x over 3, minus sign still in the middle, and then that 3 also has to go under the 16. So 4x over 3 minus 16 over 3. If either of these fractions had simplifying you could do, we would want to do that. Since the fractions don't have any simplifying, 4 over 3 doesn't reduce, 16 over 3 doesn't reduce, we're going to leave the answer like that. Okay. Let's try the second one. 11 plus 3x over 6. I'm going to pick on Jacob here. Thoughts on how to rewrite this one? If you look at the last one, the 3 had to go under both pieces, right?
Yeah, 11, 6.
Okay, so 6 has to go into the 11, so 11 over 6. And
3x over 6.
plus 3x over 6. Okay, that's the basic gist. Now, is there simplifying that we can do in this one?
Divided by 3.
11 over 6 just has to stay. 11 over 6 doesn't reduce. So we're going to keep that one as 11 over 6. However, 3 over 6, what do 3 and 6 both do? They both divide by 3. Okay, so 3x divided by 3 is going to be 1x. And 6 divided by 3 is going to be 2. So that one, there was a piece of reducing I needed to do. So 11 over 6 plus 1x over 2. They can't always reduce, but that one did. Okay. Lily, can I get you to try the next one? 15 plus 6x over 12? Yep, you got it. So 15 over 12, still a plus sign in the middle, 6x over 12. Is there reducing that can be done? So first thing, 15 and 12. What can 15 and 12 both divide by? And there is something.
3.
Mm-hmm.
Wait, was it 3?
It is. 15 divided by 3 becomes 5.
Yeah.
12 divided by 3 becomes 4. So those right there both would divide by 3. What about the 6 and 12? What do 6 and 12 both divide by?
3.
I'm not sure what you said.
3.
3? Go bigger than 3. I agree. 6 and 12 divide by 3,
What did he say?
but 6 is bigger, and they both divide by 6. So this one, we're going to divide top and bottom by 6. 6x divided by 6 is 1x. 12 divided by 6 is 2. So 5 over 4 plus x over 2. Okay. Robbie, this one is yours to set up. 4 minus 2x over 8. How do I split that up?
So you do 4 over 8 and 2 over 8?
Uh-huh. 4 over 8 minus 2x over 8. What can 4 and 8 both divide by? 4?
Yeah.
Yeah, they can both divide by 4. 4 divided by 4 is going to be 1. 8 divided by 4 is going to be 2. Minus. What can 2 and 8 both divide by? 2. And again, the calculator can help you here, right? 2x divided by 2 is going to be 1x. 8 divided by 2 is going to be 4. So the idea on that one is if you have 2 pieces added or subtracted over 1 denominator, you can split that up into 2 pieces. Okay? Okay. Unless you have questions, I'm going to keep moving. The third set, it just says to simplify. And as it just says to simplify here, you'll notice there's a negative out front. Now, I don't know if you need to, if you want to think this or not, but that negative represents what number? There's an invisible what? 1. So when you have a negative sign out front of a set of parentheses, it's a negative 1. And we're going to take that negative 1, and guess what we're going to do? We're going to distribute it. Now, the deal is, when you multiply by a negative, we multiply by negative 1, all that changes is the sign. If it was positive, it becomes negative. If it was negative, it becomes positive. So here, when I do negative 1 times positive a, well, a negative times a positive is a negative. And so I'm going to write this as negative a, or negative 1a. And then negative 1 times 5. Negative times positive is going to be negative 5. So this answer right here is negative a minus 5. You want the shortcut? I take the a plus 5 in the parentheses and I just change their signs. That's the shortcut for multiplying by a negative. Okay, who's ready to try the second one? It's negative times negative x plus 31. So if you want to think of this as a negative 1 that we're distributing, you can. Or just think shortcut. Who wants to give this one a try?
X negative 3.
And I would write it or read it as x minus 31. Okay, so it's negative 1 times negative x becomes positive x. Negative 1 times positive 31 becomes negative 31, or how I would write it is it changes to minus 31. So notice, negative x became positive x. Positive 31 became negative 31. Okay. Negative times 4x minus 12. Jacob, what do you think on this one?
What the answer is? Or?
Yeah, what happens when I distribute my negative here?
It's a negative 4x
Okay.
plus 12.
Okay. 4x becomes negative 4x, minus 12 becomes plus 12. Multiplying by a negative just changes those signs, right? Robbie, you got this next one for me? What happens when I multiply this negative times this 6m and times this minus 9n? What's been happening all these other times? Positive 4x became negative 4x, minus 12 became plus 12.
You just
Negative x became positive x, positive 31 became minus 31. So what does, when we multiply by a negative, what does 6m minus 9n become?
negative 6m plus
5. Yep. Negative 6m plus 9n. Okay. Multiplying by a negative just changes the signs. That's a good rule to know, okay? Goes right along with our negative rules. That pink paper you have goes right along with those rules. Okay, ready for the bottom half? A little bit of vocabulary here before we practice these bottom ones. A term is a number, variable, or a product of a number and one or more variables. So, for instance, 6, that's a term. We could say M is a term. I could say 9N is a term. Okay? pieces that are multiplied together are terms, as long as there's not adding or subtracting within the term. Constant. A constant is a term that has no variable. So basically, a constant is a number. For instance, 7 is a number, yes. That's a constant. -4 is a number. It's a constant. Coefficient, numerical factor of a term. So for instance, if I say 5x, this 5 is the coefficient. Okay, 5 is the coefficient of x. And then the key one to remember that we're getting ready to use here, like terms. If they're like terms, they have the same pieces. They specifically have the same variable factors. And that's what we're looking at in this bottom part. If they're like terms, we can add or subtract them. If they're not like terms, they don't have the same variables, we can't add or subtract them. So, we're going to practice with our like terms here. If there's like terms, we'll add or subtract. If there's not like terms, we may not be able to fully add or subtract. Now, this first one's kind of tricky. We'll see what happens here. 3y minus y. Thoughts on 3y minus y?
3.
No. Common mistake. 2 what? Okay, so here's what I like to make you guys think. This is 3y minus, what's the invisible number in front of this y here? 1. So what's 3 y's take away 1 y?
I just thought, because usually when there's two the same variables, you have to add that.
Not with adding and subtracting.
Okay.
You're thinking more of dividing. If the variables are the same, we can maybe cancel them out. But with adding and subtracting, they have to have the same variables to add or subtract. And then we just add or subtract the numbers in front of them. So since this is 3y's minus 1y, you take 1 away from 3 of something, you have 2 of something. So 2y. Okay, let's look at this next one. Negative 7m n to the 4th minus 5m n to the 4th. My question to you, are they like terms? Do they have the same letters?
Yes.
Yeah, they're both m n to the 4th, aren't they?
Yes.
So here's what you need to think about, is you need to think about, okay, what are my numbers out front? I need to do negative 7 minus 5. How do I do negative 7 minus 5? You can think pink paper. You can grab a calculator. I like to say change opposite, or add the opposite. So I like to say keep negative 7, change subtraction to addition, and the opposite of 5 is negative 5. Or as I said, grab a calculator. What is negative 7 plus negative 5? Negative and negative, you just add them and keep the sign. Now, so what is my answer? Negative 12 what?
And to the
Negative.
Keep those like pieces. If it was negative 7 of something, minus 5 of something, now it's negative 12 of that same something. I like this next one. Okay. There's 3 pieces this time, but the rules are still the same. 6yz plus 2yz minus 8yz.
Would it just be like
Yeah.
No?
Oh.
Would it be,
Oh,
that would be kind
Are they like terms? Are they all yz's?
Oh, yeah,
of,
yeah.
So they,
Yeah, they're all
So would it,
yz's, yz, yz.
so would it just be 0?
Mm. Because what are we doing here? 6 plus 2 minus 8.
So would it just
6 plus 2 is 8. Minus 8 is 0, right? So you could say 0yz. But here's the deal. Math Excel isn't going to want 0yz. When you have 0 of something, that is just 0. Now, you can't just say your answer is yz, because what's the invisible number in front of yz? A 1. Is this 1yz? No. Okay. Bottom row. Almost there, but we got to change things up a little bit. Got to help me out here. We've got 3 more problems. You'll get time. Okay. 2x plus 1 minus 4y plus x.
So could you add the 2x and the x together?
Okay, so my question is going to be, what are your like terms? And
Yeah.
you guys see x here and x here, yes?
Mm-hmm.
Are there any other x's?
No.
No. So what is 2x plus x?
3x.
2x plus 1x is going to be 3x. What other pieces do we have in this problem?
Y. Wait.
Plus 1.
Okay. Well, we have a plus 1. Are there any other plain whole numbers that plus 1 can go with? No, so it just carries down to our answer. We also have a minus 4y. Are there any other y's that goes with? No, so that's going to carry down to our answer. Any more like terms? No. So this one, it can't go all the way. It stays in 3 pieces. Okay. 3a minus 4 minus 7a. What are my like terms?
3a and 7a.
Okay. This is a 3a. And what kind of 7a?
Negative.
It's a minus or negative 7a, correct?
Yeah.
Because you go with the sign in front of the 7. So what is 3 minus 7? Or I would say change subtraction to addition. The opposite of 7 is negative 7. 3 plus negative 7. The signs are opposite. We're going to subtract. 7 minus 3 is 4. 7 is larger and negative, so we're going to say negative 4a. Is negative 4a my only answer?
Yeah.
Did we use all the pieces?
No.
We used,
Negative 4a minus 4.
yeah, we used 3a minus 7a, got negative 4a. There's also a minus 4. It doesn't have any like terms, but we need to carry it down. Okay? Okay. One more. Let's see how much I can trick you on it.
Oh, Lord. You already tricked us. And we don't even have
I think What did-
7y cubed z minus 6yz cubed plus y cubed z.
You already lost me.
Could they go together since they are not?
Depends who they are, if you're asking if they can
the
go together.
YZ, the Y cube Z and then YZ cube. Could they go together?
No.
So would it just be 8y cube Z minus 6yz cube?
As we look at this first one, 7y to the third z. It can only go with another y to the third z. What do you notice about this one here in the middle? It's a y z to the third. It's not the same, is it? So this one over here, though, y to the third z. What's the invisible number in front of y to the third z? 1. So 7y to the third z plus 1y to the third z is indeed 8y to the third z. Don't forget to carry down. What else do we have? Minus 6y z to the third. Those exponents are not identical. This has y to the third. This has y to the first. You can't add them. You are done right here. Okay? Okay. Your homework is in lesson 1-7 in Math Excel.
You said 1-7.
I did. It should be the one that is available today, due tomorrow.